I see we have, I started the recording. We have 38 people.
Okay.
I'm sure people will start joining in. Good afternoon, everyone. My name is Ahmed Jassat. I'm from the South African Oracle office. These sessions are going to be run monthly, where we bring in experts like Daniel and Rodrigo to come in and educate us about, and share their knowledge on the Oracle products. So myself and my colleague Ian, I hope he's online, will be trying to facilitate these sessions on a monthly basis. If you do have any recommendations or sessions that you would like to attend, please do email me. You all may have seen my email address, and we will arrange the Oracle experts to join and share the information. But that's all from me. I'll hand over to Daniel and Rodrigo to present the session. Patch me if you can. Daniel, Rodrigo, over to you guys.
Perfect. Thank you very much. This is our first session for the South African Oracle user group. And I mean, speaking for myself, and I'm sure for Rodrigo as well, we are super excited about being here today talking about database patching. My name is Daniel, and I work as a product manager in database upgrade, migration, and patching. So very short, the slides. If you want to have a copy, you can go to my blog on dohdatabase.com. There you will find the slides as PDF ready to be downloaded. Also, if you have any questions afterwards, feel free to reach out to me on social media. My DM on Twitter is open, or you can contact me on LinkedIn, and I'll be happy to help you with any questions. And with me today, I have Rodrigo. You want to give yourself an introduction, Rodrigo?
Yeah, sure. So my name is Rodrigo. I'm also a senior principal product manager. I work with Daniel in Daniel team. We also have Mike, Roy, and Bill in our team. And my LinkedIn and Twitter handle and my website, feel free to follow me in the social media, and also to ask whatever question you have related to our product manager topics. Back to you.
Perfect. So this is the agenda for today. Just a quick heads up. I live in Denmark, so far away from you guys. Rodrigo, he lives in Brazil over the pond. I'm doing the presentation on my computer. I'm sharing the screen down to you in South Africa. Rodrigo is then remote controlling my computer when he needs to advance the slides. So a lot of moving parts, long distance. Hopefully it'll go out fine. But now let's talk about installation and patches. Today, we're going to talk about Oracle Database 19c. This is the current long-term support release that we have, and this is definitely where you want to be. So when you need to patch your database, the first thing that you start out with is to download Oracle Database 19c, the base release. So you can go to oracle.com or you can go to eDelivery and simply download the base release. Then on top of that, we need to have the latest available release update. The easiest way that you can find release updates, but also MRPs and OJVM bundle patches and so forth, is to go to the download assistant on My Oracle Support. So simply input the document ID, and you can click through the wizard, and it'll tell you the exact patch numbers that you need. For instance, if you want to have the recent most release update for Linux. It is very important that you apply release updates. This is the main method we have for delivering patches to you, functional fixes, but also security fixes. And it's also important that you stay up to date. If you lag too far behind from the graph, you can see that you're potentially missing out on thousands of fixes. Not only functional fixes, something to fix or 600 or other broken functionality, but also security fixes. Release updates are the main vehicle we have for bringing security fixes to you. So please stay current and apply the recent most release update. Then on top of that, we might have a few additional fixes for you to apply. So the release updates, they come out in a quarterly cadence. In between the release updates, if we discover a very critical issue, if we have a high profile bug that we want you to fix, we will put it into this MOS node. It's called 555.1. This is one of the most important Moz nodes, and you should definitely bookmark it. In here, you'll be able to find the most critical bug fixes, and you'll also be able to see if they are fixed in their later release or in a monthly recommended patch. Which brings me to monthly recommended patches, or MRPs. So in short, what are they? Well, they are a collection of bug fixes that we deliver to you as a single patch that you can install on your Oracle Home. So that sounds very familiar to release updates. And they are kind of similar in the sense that it is a bundle of bug fixes that we deliver to you. But to understand the difference, let's look at release updates again. The release updates, they come out in a quarterly cadence. So the last one was delivered here in April, and the next one comes out in July. In order for us to deliver a high quality release update, we need to freeze the code in release updates for a period of time up to the release date. So this means that if we identify a bug tomorrow, we cannot deliver it to you in a release update until at earliest in July. Perhaps the next one in October will be the more realistic target. So from we identify a critical bug to we can put it into the next release update and for you to consume it, it can take months. To fill the gap, we have monthly recommended patches. As the name suggests, the MRPs come out monthly. We started with this concept with 1917, the October release update that came out last year. In November, we produced the first set of MRPs. So the very important bug fixes from 555.1, we compile them into one merge patch that you can download and install so that you are up to date with the recent release update and also the very last bug fixes that we have discovered. We then do another one in December, in January, February, and so forth. Every month, we put out MRPs with the most critical bug fixes for you. Of course, you can also jump to the next release update once that becomes available. I would suggest that you do that, but MRPs are there in between to fill the gap. It's a collection of one-off patches. So it's you can go and download the individual bug fixes if you want. You can go to 555.1 and find the bug fixes, but it is very convenient that we build a bundle patch for you, so there are no conflicts for you to worry about. We built the bundle for you, and you can just install it very easy on your system. The monthly recommended patches doesn't change the release number. Previously, we had release update revisions. Those bundle patches are now gone. One of the drawbacks of the revisions was that they changed the release number. So if you had 1917 and you installed the revision on top, the database would say that it was now 19.17.1. Some customers reported back to us and say this is really inconvenient. It brings a lot of confusion into our organization because now the application team thinks that there's a new version of the database out there, which is not the case. Revisions were just a few bug fixes on top of the release update. We've changed this with MRP. The monthly recommended patches are cumulative within one release update. So for every release update, for the following 6 months, we're going to produce MRPs, and all MRPs within one line will be cumulative. So you can go ahead and install the release update. You can take the first MRP, you can then take the next MRP, and so forth. Each MRP will contain everything from the previous MRPs. This is a new concept. We launched it in November last year. So for now, it applies only to Linux. We produce MRPs only for the Linux platform. If you are on some of the other platforms, you can still go to the 555.1 Moz node. You can find the individual bug fixes, download them, and install them. No changes there. We don't leave you out to we don't leave you in trouble just because you're not on Oracle Linux. But on Linux for now, we built a bundle for you, the MRP. The MRPs may contain security fixes. The release updates, it is our main method of delivering security fixes for you, and it'll remain to be the same. But if we find a high-profile security bug fix and we want to close it immediately, we will push it out with an MRP. In OCI, they haven't fully adopted this concept yet. So when you provision a new database in OCI, you cannot select from the predefined images to have MRPs on top. If you want to have a database image in OCI with MRPs, you need to create your own software image. So you go to the Oracle database session and you decide, or you click to create a new database software image. Then you can specify the release update and then a comma separated list of all the bug fixes that you want to include. So now we have the release update that you must install, and we also have the monthly recommended patches. And then are there other things for you to consider? And yes, there might be. If you go to this Moz node, we have tabs for certain functional areas in the database, like for instance, data pump. If you are using data pump frequently, you can go to this Moz node and look up information about important bug fixes for data pump. Now, we try to push as many things as we can into the release update, but in some situations, it's not feasible. And then, for instance, with data pump or Golden Gate, we have additional bundle patches that you can apply on top of the release update. So if you use Golden Gate, if you use data pump, if you use direct NFS, there are some important bug fixes for you to consume as well. Then the good news, when you install release updates, those release updates now also update the Perl libraries in the Oracle Home. If you go into the Oracle Home, there's a Perl subdirectory, which contains a full Perl installation. Now we will patch that together with release updates. The same applies to the Java installation that you can find in the Oracle Home. The only thing you need to be aware of is that the patching cycle for the Java patches is a little slower. So the Java patches you see in your Oracle Home will be at least 3 months old. If your security organization flag this and say you need to install the very latest JDK patches, you can go and download a one-off following from this Moz nodes. Also very convenient, in the release updates, we now include the time zone patches. So we install them in the Oracle Home, but we don't change anything in the database. It's still up to you to upgrade the time zone file in the database, but just for convenience, we now push them out with release updates as well. And then a final thing to note about release updates is that they can contain optimizer fixes. They most of the time contain optimizer fixes. But if the optimizer fix is in an area which might change your execution plans, those fixes are turned off by default. So we will put the good code into your Oracle Home, but it's up to you to selectively enable those optimizer fixes that you want. There is an API to do that called DBMS Optim Bundle. So if you run into situations where you need to fix something in the optimizer and you apply a release update and it still doesn't work, it's probably because you need to use the API to turn it on explicitly. Okay, so now that we have identified that you should install the base Oracle Home, you should install the release update, you should install MRPs, and possibly also some bundle patches on top. How can you actually do that? Well, first,
Daniel,
when you download patches from our Oracle support, it's a zip file.
Daniel, just one sec. If anyone has any question, please use the Q&A just to let everyone know we forgot to say that in the beginning. So sorry for interrupting you, but yeah, please people ask questions. I will be here answering for you. Perfect. So now that you have the zip file, you downloaded the zip file, what is actually in the zip file? Well, when you extract it, you will see a lot of files. These are executable libraries or other text files that we can copy into the Oracle Home. We also have in the zip file something called apply and rollback scripts. And we can use those scripts to make changes inside the database. Sometime when we produce a bug fix, we need to change something in the Oracle Home, but also something inside the database. If the scheduler has a problem and we need to change the scheduler API, then we need to recreate the DBMS scheduler package. And we do that by using SQL files or apply scripts that you will find in the zip file. When you need to apply a patch,
there are two tools that you need to use. Both of them you will find in the opatch directory in the Oracle Home. It is opatch and the data patch tool. The opatch tool, we use that to apply files to the Oracle Home. Because we need to mess with the files in the Oracle Home, where we run the database, a listener, and other components, since we need to mess with the files and potentially relink files or make files in the Oracle Home, it means that everything running out of that Oracle Home must be shut down. Once we've done that, we can then fix things inside the database. And in order to do that, we must bring up the database so we can insert new things into the database. For your reference, if you need to find out what is installed in your Oracle Home and what is installed in your database by opatch and data patch, you can use this slide for reference. There are some APIs that you can use. Now I'm going to hand over to Rodrigo to talk about some patching methods.
Wunderbar. Thank you, Daniel, for this great patching introduction. So let's start now with the patching methods, how we can patch an Oracle database. Let's see some of the methods now in the next session. So first of all, we have the in-place patching. This is the method that most people still use. We will see later on the slides, but that's I would call like an old-fashioned method. We have much better methods today to do the database patching. So in-place patching, what you do, let's say you have your Oracle Home running in 19.18. First, you need to stop your database because you're going to patch that binary that is running that Oracle database. After you stop your database, you call opatch apply to patch the binaries, as Daniel explained before. And after you patch your binary, now you start your database again. And now that you have your database up and running, you call data patch to patch the database dictionary. So here, during the downtime window, you patch both the binaries and the dictionary. So you had to have a big downtime window because you were patching two pieces of the code, both the binaries and also the dictionary of the Oracle database. However, if you go to the out-of-place patching strategy, that's the one that we recommend, it's different because here what we are doing is first we installing or cloning a new Oracle Home. So this new Oracle Home, we can patch the binaries while the other database is still running in the previous Oracle Home. So here for our downtime window, we are not considering the time that we take to patch the binaries because we are patching the binaries while the database is still running in the old Oracle Home. So now that this new Oracle Home is already patched and with the newest binaries, we stop our database and then we move it to the new Oracle Home and we start it again. So our only downtime here was to move a database from one Oracle Home to the other Oracle Home. So that's why this method is the method that we recommend you to go. Because here you are removing the patching operation of the binaries from your downtime window, okay? And now that you start your database back, you can simply call data patch to patch your dictionary, okay? So in place, you are patching the Oracle Home where your database is running. Out of place, you create a new Oracle Home, you patch it, and then you move your database from one home to the other and finally patch the dictionary. So that's the main difference between in place and out of place. So here is Tim Hall from oraclebase.com. He made a question here on Twitter asking if people use the in place or out of place. And as we can see, most of people, they are still using in place method. But again, we recommend you to go with out of place as this will make your patching downtime window shorter, okay? And there is also other advantages that we will show on the next slides. So why do we recommend you to always use out of place? First, to minimize downtime. When you go out of place, as we saw, and as I already explained, you remove the binary patching from your downtime window. Also, you avoid surprises. If you have any conflicts during applying the patches on the binary level, you will know while your database is running. You don't need to detect that when you are during your downtime window, okay? So we remove those surprises for your downtime window. It's also much easier to roll back because your original home is preserved. So if you have any problem and if you want to go back to the previous Oracle home, you simply move back that database to the previous Oracle home and start it from there and call data patch again. And there are two ways for doing the out-of-place patching strategy. One is installing a brand new Oracle home and patching it, and the other is cloning your existing Oracle home. We recommend you to always install a brand new Oracle home instead of cloning. And the reason why is because you will avoid some disk footprint and slowness, and we will see also on the next slides. So if you go with the out-of-place patching strategy, also ensure that you copy all the configuration files from one home to the other. What are those configuration files? Password file, ASP file, TNS names files, and there are much other files. Daniel has a great blog post mentioned most of them. But if you use auto-upgrade for doing the patching operation, because auto-upgrade can also move your database from one home to the other, then auto-upgrade will take care of all of those files for you. So we strongly recommend you to go with out-of-place patching strategy, especially using auto-upgrade utility. Auto-upgrade will handle all those files for you automatically, okay? Now, let's talk about other methods for patching your database. Let's say you have a standby database for disaster recovery. If you have one, we strongly recommend you to go with standby first patch apply strategy. We have this Moz note documenting this strategy, and let me explain how it works. So with standby first patch apply, what you do, as the name suggests, is first you patch your standby node. So you stop your database. Let's say both databases are running in 1918. 1918 is from January this year, right? So you have both databases running in January RU, and you want to go to 19.19, which is the April RU. So first what you do is you clone or install a new Oracle home. Again, we recommend you to install a new one and apply the latest patch on top of it. Then again, you patch both sites. So you will bring those two Oracle homes that are totally outside of the scope of your current operation because they are cloned Oracle homes. It's not where your database is currently running. You patch both of them and bring them to 1919. And now again, as the name suggests, first you do the standby node. So you move your standby to the new Oracle home and you start it there, okay? Now we have a totally optional step that we strongly recommend you to do. What you can do is you can convert your standby database into a snapshot standby. Call data patch in that snapshot standby to test the data patch process in the snapshot standby before you run it in your primary database. And you could potentially also test some fake workload here just to check if you won't have any issues after you patch your environment. After you test it, again, this is an optional step, you convert it back to a physical standby, okay? So now we are back to the original operation. We have our primary database is still in 1918, and our standby database already on the 19.19 Oracle home. Now that's the downtime that you have during this operation. You do a switchover, and usually a switchover is something very fast. So when you use this standby first patch apply strategy, your downtime during patching is just the time it takes to do this switchover. And we have now our former primary being the standby in the older Oracle home release. We now move our former primary, which is now the standby, to this new Oracle home. And after finally we have both sides running in this new Oracle home, we call data patch to patch the dictionary. Something very important is that we can only call data patch to patch the dictionary when we have all the nodes, or in the case of a DR, of a standby, both sides and all our standby environments in the new Oracle home. We do support having the dictionary in a lower release than the Oracle home, but we don't support the opposite. So that's why you need to wait until all your standby nodes are in the new Oracle home, okay? And that's it. That's the only downtime it took was during the switchover. And of course, you can optionally here add a step for switching back to the old primary database. So that's the standby first strategy. The only requirement for this method to work is, of course, you need to have a standby database, and also the patch must be marked as a standby first. So the patches in the README file, they have a flag that will tell if they are standby first installable or not. All the RUs, they are standby first installable, okay? And if you want to really go with zero downtime, then we have what we call rack rolling patch. That's the way that you can really achieve zero downtime. You don't need to stop your production to have your database patched. So let's see how this strategy works. So for rack rolling, what you have here is your user, your connections, your database instances, each of them in their Oracle home. So you have 3 nodes in this example, and of course, a single database. So let's see what we do here. First thing we need to do is we need to clone or create a new Oracle home, and we apply the patch on that cloned Oracle home, okay? So that cloned Oracle home will be in the higher release. Again, we can do it without impacting the operation because there is no database running in this new cloned Oracle home that we just deployed. After we have this new cloned Oracle home, we do what the name suggests, is rack rolling. So node by node, we move the database to the new Oracle home. And that was so fast that I will go back here with the animation and play it again. So here we see first node 1 moving to the new Oracle home, then node 2 moving to the new Oracle home, and finally node 3. Okay, so that way we always had an instance running on this environment, so there is no downtime. Okay, and finally, when again we have all the databases placed in the new Oracle home, remember what I said in the previous slide, we need to have all of them in the new Oracle home. We call data patch to patch the dictionary. We cannot patch the dictionary unless all the databases are already running in the updated binary, okay? So that's the rack rolling strategy. There is no more excuse to not patch your environment saying that you cannot afford the downtime. Right? If you have a rack, you can always go with this strategy, given the patch has a rack rolling flag. Just like I said, for standby first, the patch needs to have the rack rolling flag on the README file. And again, all the RUs are rack rolling and standby first. This is a guarantee, okay? We cannot put patches on a RU if they are not meeting those 2 requirements. All right, a lot of people ask us, hey, can I have the GI and the database in different versions? We do support that, but we don't recommend it. And why we don't recommend it? Because we can't test all the combinations possible of a database version with a GI version, right? So we have database versions since 19.3 until 19.19. Those are 17 versions, and the same for GI. If we had to test all those combinations, would be 17 multiplied by 17 combinations. And we can't do that because we have a lot of massive tests that run when we deploy RU. So usually what we test in our test farms here within Oracle are the GI and the database at the same release. So we do support, again, that you run in different versions, but we don't recommend because you may find a very odd bug that we haven't tested, okay? If you go with different versions combinations. So for example, you can have here, as we see in these slides, a GI in a lower version than the database, or a GI in a higher version of the database, or even nodes with different GI versions. But again, to make it very clear, we support, but we don't recommend it, okay? And as I said already on the previous slides, all our RUs are standby first installable and rack rolling installable. So please abuse and use these strategies when you are patching your database to the latest RU. This will make your downtime window much shorter and will make your managers much happier. All right, Daniel, back to you to talk about GI patching.
Oh, yeah, cool. I mean, just talking about rack, then also it makes sense about talking about grid infrastructure. So the following that I'm going to talk about is applying patches to Oracle Grid infrastructure. But the strategies that I'm going to show you, you can actually use those as well to patch the database if you want. The most simple way to patch Oracle Grid infrastructure is what we call the all node methods. When we do that, we take down all the nodes in the cluster at the same time. So this means that we have a database outage. We then patch them and bring them back online. This is easy, just straightforward, but you have a database outage. So it's not preferable. But you need it sometimes if you have to install patches that is not rack rolling installable. If you have such patches, you can also use this approach, which we call minimum downtime. Here we divide the nodes into 2 batches, and then we take down each of the groups in different order. First, we take down the first group, we keep them shut down, and we apply patches to the first group. Now, because we must be able to install non-rolling patches, what we will do here is that we will take down the second group of nodes. So now we have a database outage until the first group can be brought back online. But the first group is already patched. So the outage that we have here is just the time that it takes to shut down GI on one group and bring it out on up again on the other group. So typically we are talking about minutes here, but it's still much faster than the all node we saw before. But of course, the best way to do it is in a rolling manner where we take down each node in a rolling fashion. We apply patches to that node, we bring it back online, and then we proceed with the next node. The patch must be rack rolling installable. Release updates always are, so that should be pretty much straightforward. But you should be aware that while you're taking down instances in your cluster, all the other instances must be able to handle the workload. In the demonstration here, I have 4 nodes. If I take down one of the nodes, it means that the cluster is running at 75% of its capacity. If you just have a 2-node rack cluster, then it's 50% that you take down by removing one instance. And in that period, the other node must be able to handle the entire workload. A variation of rolling patches is what we call rolling in groups. It works in a similar way as we just saw with rolling, but here we are working on groups instead. So for a 4-node cluster, you would take down 2 instances at the same time, you would patch them, bring them back online, and then proceed with the second group. Again, here there's no outage because we still have instances at all time up to serve access to the database. Rolling in groups is preferable in some situations where you have issues with draining. I'm going to talk about draining just in a little while. We recommend that you use rolling patches whenever possible. This is our recommended method, but it requires that you use that you can effectively drain the instances, that the application that uses the database can move to other instances when we need to take one down for maintenance. When you start with a rolling patch apply, you should proceed and complete the patch apply of grid infrastructure, but also on the database, you should proceed and make it happen as fast as possible, and ideally within 24 hours. When a cluster, either GI or the database, is in a rolling patch state, some internal functionality is disabled, and it is desirable functionality, so complete the patching as soon as possible. Draining is a concept which is very important in order to have success when you need to patch clusters. How does draining work? Well, when we need to take down one instance for maintenance, if you use the tools in Oracle database or in grid infrastructure, that instance will say, hey, I'm about to go down for maintenance. It'll send out a fan event to all the users that are connected. It goes via the database client. We send out a network package. So now the client is notified this instance is going down. I better move on to a next instance. Also, the instance contacts the scan listener. So any new connection will be sent to those nodes that are not about to go down. Then at a proper point in time, the application can lose the connection to the instance that is about to go down and then reconnect to another instance. Depending on which client driver you use, there are different methods of handling this. Typically, you have a client with a connection pool underneath, and then the client will ensure that the idle connections to the instance going down will be ditched and new connections will be made to the good instances. This is how draining works, and it is important in order to achieve patching success, especially when you want to do rolling patching. Oh yeah, sorry. Then when all the users have moved to the remaining instances, we can then do the maintenance on the instance going down and then proceed in a rolling manner with the all instances until we have been all the way through. To read more about draining, to read more about how you can configure your client applications to react well to fan events, to ensure proper draining, you should read the maximum availability guidelines. They have details on configuring connection strings and which driver to use and so forth. If you're using DataGuard and if you have GI or RAG databases, there is an alternative that you can use, especially if draining is a problem. It's kind of similar to the standby first approach. Here we have a standby site sitting there doing nothing. And the first thing that we do is that we patch the standby site. If we don't have any read-only connections on the standby, we can bring down the entire cluster and do all node patching. So now the standby database or the standby site has been fixed. It is patched and run on the new patch level. Then we do a DataGuard switchover. All the connections from the unpatched site will then disconnect and reconnect to the standby site when it is up. And then we can proceed patching the former primary, which now serves as a standby. So here, the only downtime or the only interruption we have is when we do the DataGuard switch over to the alternate side. This approach, you can use that if draining is a problem to you, if you have an application that doesn't react to fan events or doesn't comply with the maximum availability architecture. And then we patch. Good. When you need to patch the grid infrastructure home, the Oracle home making up the grid infrastructure, you can do it in two ways, like with the database. You can do it in place where you override the existing Oracle home, and you can do it out of place, create a new grid infrastructure home, do the patching in advance, and then simply switch the services to the new GI home. I strongly recommend that you use out-of-place patching for grid infrastructure as well. It really minimizes risk, it minimizes outage, and it ensures that you don't run into, or it minimizes the risk of running into problems when you do patching and when you're about to take an outage. Good. When we talk about patching grid infrastructure, it is also worth to consider whether you also want to patch the database as well. You can do it either separately, so patch GI first and next weekend patch the database, or you can do it all together. Each method is supported, and it's more a matter of personal preference whether you want to take the database and patch it together with GI or not. Of course, if you patch the database and GI together, you only have one maintenance window, but it will be slightly longer because we need to handle more in one maintenance window. If you decide to patch GI and the database separately, one word of advice is that you should patch them fairly close to each other, like for instance, 2 following weekends. So in the first weekend, you patch GI and the next weekend you patch the database. Don't patch GI and then wait 5 months or 6 months before you patch the database, because ideally you want to have the GI patch level and the database patch level running in sync, like Rodrigo told us just a few minutes ago. A few tips that can help you achieve success when you need to patch grid infrastructure. The first advice is to use the cluster verification utility. It's a lightweight check that can analyze your grid infrastructure installation and see if there are any things you need to be aware of before you start the patching. You can run the cluster verification check before and after the patch apply to ensure everything is okay. Ideally, you use the cluster verification utility through ExoCheck or AuraCheck. But either way, at least ensure that you have the latest version of the cluster verification utility. When we talk about grid infrastructure, like with the database, ensure that you have the recent most release update and MRPs installed. And again, let me emphasize, keep the database and GI patch level in sync. When you need to patch here in July, ensure the GI and the database both go to 1920. To ensure smooth draining of your instances, to help drain the instances, ensure that your application complies with the maximum availability architecture. Once you have achieved that, you should also look into application continuity and transparent application continuity. It can hide unplanned outages, but it can also make it easier for your patching operations if you have clients that are taking too long to drain from an instance. And then finally, OPatch is the tool you use as well to patch the grid infrastructure installation. Always use the latest version of OPatch. When you get a grid infrastructure patch file, there's a README telling you the minimum required OPatch version. But you should always get the latest version from my Oracle support, even though it's not necessary. The OPatch team, they are good at fixing errors, so it is really a good idea to always use the latest version of OPatch. That was it about GI. Now I'm going to hand over to Rodrigo, where we can talk about patching the database.
All right, I was answering one question here. So thank you, Daniel. Let's see some patching insights now. This is more internal stuff, but that's very useful. So first thing, always use latest OPatch. Some users complain about not being on a required OPatch, but we always recommend you, even if you have an older OPatch that is applicable to that RU, we always recommend you to, even though, use the latest one available in oracle.com. So always put that step as a requirement during your patching workflow operation, okay? Always use the latest OPatch. You will see why on the next slides. So if OPatch takes too long, use out-of-place patching with a brand new Oracle home instead of cloning an existing one and applying the patch over it. And the reason why is that when you have a brand new Oracle home, let's say 19.3, then you apply the 19.19 RU, you don't need to roll back anything because you are in a brand new Oracle home applying, that is in the, let's say like in the starting point, applying a patch on top of it. When you clone an Oracle home and apply a patch over it, then you need to roll back the previous patches if you have any conflict to apply the new one, okay? So for example, let's say you are in 19.18 Oracle home, you clone it and you apply 19. The OPatch tool will roll back 19.18 and apply 19.19, okay? So having a brand new Oracle home, avoid that rollback phase. So again, the problem of reusing or cloning Oracle home is bigger disk footprint. We will see on the next slide an example, and also the patching runtime increases, right? We are doing out of place. Sometimes we don't care about patching runtime because it's gonna be doing the patching operation while our production is running in the different Oracle home, but still it's good because of the disk footprint. So here is one of the root causes of long OPatch runtime. Again, we are talking about binary patching. Binary patching should always happen outside your downtime window. So one of the biggest problems is because of this OUI patch.xml. Okay, so this OUI file, it has inside all the patches that were ever applied and all the inventory for the binary patches of your database home. So whenever you run OPatch, when it needs to do a space check or a conflict check or even the apply phrase, it will always go to that file. If that file gets real big, then it will take longer for your OPatch operation. And since OPatch version 37, I don't recall when this version was released. I think it's like 4 months back. April?
Yes.
Okay, so yeah, 2 months back. Well, we have this new option, delete inactive patches, that will drop all the old patches information from your Oracle home that you would no longer need. Okay, so that's what they created to solve that patch slowness problem when you are patching the binaries. And here, let's see an example. Let's say you have a 19.3 home that over the time you applied several release updates. So you applied 19.6, then later 19.7, 19.8, finally 19.18. And all those operations you're doing in place or doing out of place, but by cloning your existing Oracle home. So in your Oracle home, you have the inventory of all those past patch applies, and also the rollback files and the apply scripts for them. So that makes the disk footprint much bigger for this Oracle home. If you now try to apply a new patch on that Oracle home, here is an example. It took 19 minutes just to run the old patch apply step. But if you delete the inactive patches, so you delete all the history of previous patch that you no longer need, and you do the same operation, you see that you go like for 25% of the time. It's 1/4 of the time. It's 4 minutes only compared to 20 minutes, okay? So again, this is something very useful when you are doing a cloning Oracle home operation or in-place operation. If you're doing out of place, installing a brand new Oracle home, then you don't need it because a brand new Oracle home doesn't have any patch inside, okay? So as I said, the recommended steps is always when you do out of place with a new Oracle home is first you unzip the new Oracle home 19.3 from oracle.com or eDelivery. Then you update all patch, always go with latest release. And then you install that new Oracle home. You can optionally use this apply RU and apply one-offs flag. So you install the Oracle home with the patches applied already. Okay, so that's the way we recommend you to go when going to the out-of-place patching strategy with a brand new Oracle home, doing mainly those 3 steps here. All right, when you are patching a database, it's important that, of course, you are patching the database, or your database cannot be turned off, or we cannot patch the dictionary. How are we going to access the dictionary, the DBMS packages to patch them if your database is shut down? So you need to start your database to patch the database, I mean the dictionary, and it's also important to open all the PDBs. If you have a closed PDB, it will be skipped during the patching operation. We will only patch the PDBs that you have opened when you invoke data patch, okay? And of course, after you start your database, you finally invoke data patch, and this data patch utility, as Daniel showed on the first session of this webinar, is inside all patch folder in Oracle Home. Okay. There is also a new option in data patch, which we call data patch sanity checks. You can, before calling data patch to patch your database, you can run those sanity checks to see if there is any potential problem that you would face when you invoke data patch. That's something very new. We have here the link for this, but I will show shortly how it works. So you run data patch with -sanity checks, and it will check if all the component stats are okay, if you don't have any PDB violation, and much more. If you have all your table spaces, especially the system table space, not in read. Actually, system table space can never be in read-only mode, but it will check some table spaces if they are okay, if there is no backup job running, and much more, okay? So this is something that we recommend you to do before you call data patch to patch your database dictionary. Also, we recommend you to always recompile all invalid objects before invoking data patch. And why that? Because if you have anything that become invalid after your patching operation, you will know exactly what the patching operation made invalid. If you have like 1,000 objects that were invalid before you call data patch, and you still have 1,000 objects after you call data patch, it's hard to tell, or you have like much more objects, it's hard to tell which objects now became invalid because of data patch. So always clean out everything that's invalid. This will also save time, because if some of those objects are invalid, Oracle will always try to recompile them when they are called, okay? So do this recompile before calling data patch.
Oops, I see a poll popped up, Rodrigo. That's probably why you can't remote control.
I knew it was your fault.
Try again.
All right. Okay. So let's go back to the patching timeline. First, you do the sanity checks, data patch minus sanity checks. For some
That's
reason,
your own
my
fault.
Alexa started. Alexa, para. Okay. Okay, so first you do the sanity checks, then you recompile all invalid objects. Then you start your database, because here we are doing the out-of-place patching strategy, right? You move it to the new Oracle home, and then you start your database and all the PDBs. And this is something important. A lot of people ask us, do I need to open my database in upgrade mode or restricted session for doing the data patch call? No, it's not needed. You don't need to go. This was a requirement a long time back, especially for Java patches, but it's no longer a requirement. So you can simply open your PDBs and your database in normal mode, okay? So you open it, you start all your PDBs. And that's something also maybe a new information for you, but this is something very cool. You can have your database users connected in your database while data patch is running. So you don't need to wait until data patch process. In other words, you don't need to wait until your database patching operation finishes to allow your users to connect. Again, Daniel has here the link, excuse me, to a very detailed blog post about that, but I will try to explain here in a couple of minutes in a few slides. So again, you start your database in another Oracle home. I think I also had a question about that here in the Q&A. So users can connect at the point in time where your binary is already patched. You don't need to wait for the dictionary patch to happen to allow your users to connect. And now you call data patch, and data patch will patch your database dictionary and recompile also the invalid objects at the end. And patching is completed after data batch finishes, okay? But you may ask, hey, wait, imagine now I'm running a DBMS stats to gather table stats of my schema, and at the same time, data patch is trying to replace this DBMS stats code with a new code. What's gonna happen? We have a concurrence here. What data patch will do, it will wait until your process, your gather table stats process finishes to then create or replace the package body. That's done automatically through the wait queue. So data patch will trigger that create or replace package command, and then it's gonna do a wait queue, okay? We have concurrence, we have potential problems, but that's a very low risk that we have when you have users inside. And data patch will wait for 15 minutes by default to acquire a lock on that object that might be locked by another operation, and then will die. If data patch die, then it will fail and you will need to run data patch again afterwards, okay? So what you can do is you can officially play with this DDL lock timeout to make it better. We don't recommend that. If you have an error, then simply call data patch again, or you can, during the data patch operation, you can find the blocked sessions to kill them, okay? You can simply open your $V session, see what sessions are calling that object that data patch is trying to patch, and officially kill them, okay? Kill those sessions. So data patch uses this table. This is a table inside the database to keep all the registry of operations that happened in your dictionary. This is not an inventory of what you have patched. That's not an inventory, let me rephrase it, with the patches that you have in your database. That's actually a registry table. If you patch, you have a row. If you roll back that patch, this will become a second row. If you patch again, this become a third row. So that's an inventory, not an inventory, a registry of all the operations that ever happened in your dictionary related with patching. And if you're not sure if your dictionary was patched, you can simply run data patch again. Data patch is smart. Data patch will skip the patching operation if it detects that there is nothing to do. So you can potentially run data patch as many times as you want, and probably it will only patch during the first call, and all the other calls will simply ignore in case that patch operation was already done in your dictionary. And that data patch also recompiles any invalid objects that were generated during the patching operation, and only the ones that were invalidated during patching operation, right? So for example, what data patch will do is get the list of objects that were invalid before data patch was called and compared with the list that was after data patch was called. It will do a minus between those two lists and only recompile the ones that were invalidated during data patch operation. But if you have more than 300 objects that are invalidated during data patch operation, then it will simply skip that step. And then you need to do it manually afterwards, or the objects will automatically be recompiled on usage. You can change that threshold using this parameter for data patch. Okay. So here again, it will recompile only if less than 300 invalid objects. And if you have more than that, then we recommend you to manually call utlrp. Ahmed, do we have time? Because I see it's already on top of the hour. Can I extend for more 5 minutes?
Yeah, sure. Please do extend for 5 minutes. To the 65 people online. I see no one leaving.
Okay.
Please extend for 5 minutes. Yeah, go for it.
All right. Okay. So I think I can close in 5 minutes. All right. You can check all the data patch operations through this log file here we have inside SQL patch folder. You can grab, for example, for recomp thresholds. And here we see that in that blue lines, let me go back here. We see that before patching, we had 0 invalid objects. And after patching is still 0, and what was the threshold, and for each PDB. Okay, so you can check if your objects, how many became invalid after you call data patch through this log file. All right, now going to the next slides, last slides actually. When you call data patch is a tool here that's available inside OPatch folder. However, if you do a VI in that file, you will see that's a very small file with just one single line. Actually, data patch inside OPatch is a simply wrapper that will call SQL patch in Oracle Home. And that's another wrapper that will call SQLpatch.pl. So the first thing here to notice is that when you patch your OPatch, when you change your OPatch folder, you're not actually updating your SQL patch tool, because SQL patch tool is in a different folder. Again, OPatch/data patch is just a wrapper. So you're updating a file that has a single line, okay? The way we update SQL patch or data patch, SQL patch and data patch are synonyms. The way we update them is through RUs. So when you apply RU, then data patch will be updated. Okay. Daniel, I think, okay. Do you have a pop-up, Daniel, or not?
No, let me check. I didn't touch anything, I swear. No, it's my PowerPoint. Yeah, let me just yeah.
Okay.
Try again.
Yeah, working now. Thank you. So finally, I think this is the 2 last slides. What's the patch apply sequence when you call data patch? Let's say you are going to a new Oracle Home that has new Java patches applied, new bundle patches, new one-offs. How data patch will build the patch trail for this new Oracle Home? What it's gonna do first? Is it gonna do first the one-offs or the Java? So we have a rule here. Always Java has a higher priority because Java patches are most important and they can impact other patches. So data patch will always handle Java patches first. Then it will roll back any extra one-off, apply the bundle, and finally, at the end, will apply any extra one-off. So it will remove the extra one-offs, and then in the end, will apply the missing one-offs that you don't have in your dictionary. And let's see that work. So let's say your binary registry has patch 4 for Java, patch 5 for bundle. Bundle patches can be a RU, for example, and patch 6 for one-off. While your SQL registry, so your dictionary has patch 1 for Java, patch 2 for bundle, which can be a RU as well, and patch 3 one-off. And now you call data patch. What's gonna happen? So again, as I said, Java always comes first. So data patch will roll back the extra Java patch you have in your dictionary because it must match your dictionary with your binary. And then apply in your dictionary the patch floor. So this will make Java patch match the dictionary and the binary. Now it will roll back any extra one-off. So we have here the one-off number 3 that we have in the dictionary, but we don't have in the binary. So it will roll back that one-off. And now it will resolve the bundle delta. So we have in the binary patch 5 and in the SQL registry in the dictionary patch 2. So it will here do a delta. So what do I mean with a delta? When you, for example, when you apply, you are in 1916 and you apply 19.19, the data patch will not roll back 1916 to then apply 1919. It will just apply the things that happened in the middle. So it will apply 1917 and 1918 scripts only. Okay, otherwise it will take a lot of time to do a data patch operation because it will need to roll back 1916 to 19.3 to then apply 19.3 to 1919, which doesn't make sense. Okay, so that's what we call as a bundle patch delta. And finally, it will apply any extra one-off that you don't have in your dictionary. After that data patch field is built and is executed, you have a match of your binary and SQL registry. Okay? And I guess this is the real last slide. So I'm saying this is the last slide, 5 slides already. So I guess this is the real last slide. So this is something also important. When you run data patch will store all the scripts that it generates to apply and roll back that patch inside this table, registry$SQL patch in this column, patch directory. That column patch directory will have a zip file, which is a zipped as blob of all the patch apply and rollback scripts. And you may ask, hey, why do you store this inside the database, not just outside the database? And the reason why is, imagine you are moving that PDB from one Oracle home to another Oracle home that doesn't have that information about that patch. So data patch will get the rollback scripts to make the PDB match that Oracle home binary. So that's why we store that information inside the dictionary as well. All right.
This is the last slide.
This is the last slide. Patching, finally, the last slide. Now I believe it's really the last slide. When you open the patch zip file, you'll see that each component is a different folder and a different SQL file in the zip file. So data patch will skip any component that you don't have in your database. So don't have all the components in your database if you don't use them. Just have the components that you use. For example, let's say you don't use Oracle Text, or you don't use Oracle Spatial, or for whatever reason you don't use Database Vault. So we recommend you to not have those components on your PDBs if you're not using them, because this will make the patching operation longer for something that you don't actually even run, okay? And finally, thank you everyone for joining our session. Sorry for passing almost 10 minutes here. Again, Ahmed, thank you for inviting us for this Oracle User Group session. It's our pleasure to be here. And let's see if we have any question here in the Q&A.
Yeah, while
Yeah.
you're busy answering the questions, I just would like to say thank you to Daniel and Rodrigo for, taking out the time of your day and, sharing this information with us from South Africa and our neighboring countries in Africa. To the 65 people that are in the room, and both Daniel and Rodrigo, the South African Oracle User Group will be having a conference from the 5th to the 7th of November in beautiful Cape Town. Everything is on the website, all the details. Please, open invitation to all to attend. Thank you very much. That's all from me. Rodrigo, you want to answer those questions on the chat for us?
Yeah, I can start out. There's a question: is removing all patches an online process? So using the opatch util delete inactive patches, is that an online process? And yes, you can run that while the Oracle Home is in use, but I would recommend that you run the utility before you move databases in there. So if you need to use in-place patching, or if you need to use cloned Oracle Home, when you clone the Oracle Home, then run the opatch cleanup utility, and then move the databases in there. You can do it while the database is running, but why take the risk when you can run it up front? There's also a question about the document ID for the database documentation. Go to my blog on dohdatabase.com. There you can find the slides, and it has the link to the documentation. Let me put it into the chat. Let's see here. No, I can't do that. So it's dohdatabase.com. I don't know. I can't enter something into the chat for whatever reason. Anyway, dohdatabase.com. Let's see other questions. What is your recommended method for automating GI and database patching? Well, for the full stack, I would consider fleet patching and provisioning. If you have many databases to manage, fleet patching and provisioning can really add a lot of benefit. Normally, it requires an additional option, but if you have targets that have the rack license anyway, you can use them with fleet patching and provisioning. What I also like about fleet patching and provisioning is that it can also patch your entire Exadata stack. So if you use Exadatas, well, it can patch the storage cells, dump zero, and all that very easy with fleet patching and provisioning. If you don't have that, then I guess you would need to resort into to do the old or to write the automation yourself. I have seen some open source frameworks for doing it, but from an Oracle point of view, fleet patching and provisioning is the option is to look into. Fleet patching and provisioning. Can we have a seminar on that? And I'm sure you can. Ahmed, I'll get you in touch with Philippe Fierens. He's the product manager for fleet patching and provisioning, and I'm sure he would love to come and talk about that. I'll get you in touch.
Thank you very much. Thank you.
Let's say, are there other any link to information? Again, go to my blog, dohdatabase.com, and you can get the slides. You'll find everything in there. Otherwise, reach out to us. Our email at Oracle is always the entire name with dots in between, or you can reach out to us on social media. If you have trouble finding us, reach out to the organizer and he can get us in touch. No problem there. Have a question about the Golden Gate merge patch. If you could put a little more details into the Q&A, I'll be happy to see if we can answer it. Is the cleanup done by Oracle engineer for supercluster environments as a pre-check activity? I simply do not know, but print out the information, and next time you see them, ask them whether they do it or not, and if they don't, then it's a good idea to do it. Let's say you can patch them. So let's say you've created a new Oracle Home and patched it successfully. The next time you patch again, are you required to create a third Oracle Home, or can you reuse the old original Oracle Home? So either way, it works. You can keep on creating new Oracle Homes. I've worked with customers that do that all the time. So they always have the current home and the last home. When they install a third home, they deinstall the first home. So they can always roll back to the previous home. I've also seen customers that main 2 Oracle homes and then they switch in between. Either way it works, but I would say with the last method where you switch between Oracle homes, you will keep this patching history. You will carry around a lot of old patches. So if you decide to use that method, it's very important that you use the new OPatch cleanup utility. Good. No more questions.
No more questions. I have a recording. I will put it up onto our website. Thank you guys, and looking forward to hosting you in South Africa in person. Please, let's not do the Zoom thing.
Let's see.
Thank you all.
Okay. Thank you. Bye-bye.
Bye.
Bye-bye.